Hello, I'm Rodrigo Moneda.
Hello, I'm Nassim Mosgari.
And I'm Ivan Paskevich.
And we're going to be explaining to you how shifting graphs work.
We're going to call this line f of x. We're going to add function f of x1, which is y equal x plus 1. So okay, so this function, so we're gonna see that this function shifts 1 point up every point of the cover. And here we have our function f of x1. Then we are also going to add the function f of x2, which is y equal x minus 1. Which is going to be the opposite of the last operation, where every point is going to shut down. And we're going to have this function here. And there we are.
Okay.
Yeah, you can cut. We're going now to show how to shift this line, but horizontally, by adding the function f of x3, which is y equal x minus 3. There we go. So we can see with this cover that all points of this function are shifted in the right with 3 points away. So this is gonna be here, here, and here. Okay, now we are going to add the function f of x4, which is y equal x plus 3, which is gonna be the total opposite of the last operation. So we can see that all points from the original cover are going left this time. And this one. And we have our new function.
Yeah, okay. I am going to show how to shift this line vertically. We're going to call this function f of x. We're going to add the function of f of x1, which is y equals x squared plus 1. Here I'm gonna show you how f(x)(1) is y equals x2 plus 1. And now we're gonna add the function f of x1. And now we're gonna draw it. And we're gonna call this line f of x1. Now we're going to add the function f of x2, which is y equals x squared minus 1. So as I said, it is called x squared minus 1. And now I'm gonna plot it. And it's just going 1 point down. It's easy for you to do. And here it is. And we are gonna call this f of x2.
Okay.
I am going to show how to shift this line horizontally. We're gonna call this function f of x. Now we're going to add the function f of x3, which is y equals x plus 1 to the squared. So let me write it. F of x3 equals y, which equals x plus 1 squared. And now I'm gonna plot this line. And now I'm gonna draw it. And you can see it. Now we're going to add to the function f of x. And remember, guys, that you always need to write the function you are using. Okay. Now we're gonna add the function f of x4, which is y equals x minus 1 squared. So f of x4 equals x minus 1 squared. Now let's plot it. Okay. And now we have it. This, remember, as I said before, always put what the function you're drawing.
Okay, so now we're going to see both horizontal and vertical shift at the same time for this function y equals x. So we're going to call our function f of x1. And it's going to equal y equals x plus 2 minus 3, for example. So this means that, first of all, horizontal shift in the parentheses, so every point shifts 2 units to the left. And then, because of the minus 3, every point is then going to shift 3 units down. So 1, 2, 3, 1, 2, 3, and 1, 2, 3. So then we can draw our function our new function f of x1, and you can see how every point shifted 2 units to the left and 3 units down. 2 units to the left, 3 units down, and finally 2 units to the left and 3 units down. And there we go. Listen. And now we're going to see how this function y equals x squared shifts both horizontally and vertically. So we're going to call our new function f of x2, and it's going to be y equals x minus 3 squared plus 1. So as the other function, we start with the horizontal shift, so every point shifts 3 units to the right. 1, 2, 3. And then every point is going to shift 1 unit up. So 1, 1, 1, 1, and 1. So now we can draw our new function and call it f of x2. And you can see how every point shifted 3 units to the left, to the right, and 1 unit up. 3 units to the right, 1 up, and it's the same for every other point.
Thank you very much.
This has been Nassim Wasgari
Rodrigo Gamoneda,
And Ivan Paskiewicz.
showing you how to shift functions.
hope you like it.